Now I'm going to give mine. I'm gonna share my screen. I hope everyone can see my slides. So my topic to inspire the discussion later is that I would like to use the topic on brain and mind inspired artificial general intelligence for symbiotic society. I think by symbiotic society, I connect my research to Siemens and also Michael's vision, so that we're on the same page. For some of the previous research in AI, what you can see something like this: a behavior level simulation of natural intelligence. Well, from the mechanism side, many people don't really care whether the human is doing this way. Well, the problem then could be that you think that this is, kind of a human hand, but actually it's a kind of a cute rabbit who's playing human hand. So this is when people ignore, the mechanism side for creating intelligence and how it can go wrong for the perception of human to artificial intelligence. So I think this is why, like decades ago, that people like Francis Crick also argued that unfortunately most of these neural nets are not unrealistic in important aspects. So I'm gonna give a preliminary discussion on why developing AI inspired by the brain and mind is the safest approach for human AI symbiosis. By that, what I mean is that first, really, that we need the recognition from the human society that AI is safe enough to explore wisdom. One of the reasons is that the mechanisms is similar or inspired by the human intelligence at some levels of abstraction. So when people are familiar with the mechanisms and how when you shake hands with other people, the reason is that you get to know that this is because this is another human, and people like handshaking in general when meeting for the first time, or you would like to show your friendship or your willingness to interact. So you shake hands with other people. Well, then you shake hands with robots. Well, when people like me and other colleagues in here that get to know that this could be risky because the mechanical design for now is not safe enough, especially for children. Then we would not like to to suggest children to shake hands with robots, especially when many of them are not stable and not human-like by its design. And also, I would like to argue that the human brain and mind is an evolving product of nature, and fewer safety and security risks have been partially filtered out through evolution. So you get fewer problems for that if you're making a evolutionary network starting from the very beginning, and then you will meet many problems. And also a computational continuation of natural evolution. I think that's something following the evolution in a computational way, while inspired by nature, would be much safer. So this is why I think a brain and mind inspired AI is one of the safest approach if we wanted to develop AI not as a tool, but like quasi members and friends, like or other beings, like what Shimon mentioned at the end of his talk. So not only you need, these building blocks, inspirations, learning principles of the brain and mind. Well, at the cognitive function level, you need self-organized mechanisms that route these different cognitive functions to achieve even more complex behavior at the mind level. So we need mechanisms, building blocks from the brain. Well, from the behavior point of view, we need the behavior to be similar to human, and also to, from the mind level. So this is why in my lab we developed the brain-inspired cognitive engine, which is basically a spiking neural network-based AI engine for brain-inspired AI and brain simulation. So basically we use different type of neurons, different plasticity principles from neuroscience to replace what we have in like something like the backpropagation and other manually designed learning principles for machine learning, and then to create different versions of the network and then synthesize them together in a coordinated way from the mind level for these different cognitive functions. So this is what BrainCog did in different versions of the embodiment of the embodied robots, helping the UAVs to explore the environment more autonomously, avoid obstacles by themselves, helping not only to help the robots to to do social robots work, like and also home robotics work, to wipe the floor and to swipe the board, and also to reorganize the room, but also more importantly to higher levels of cognitive functions like self-recognition in the mirror, and also theory of mind, that is cognitive empathy, to infer what the other robots are thinking about in facing of different problems. So for the brain simulation part, because just now, like I said, the goal is not to simulate the brain. The goal is to use computational models to explore the computational nature of the brain, and then to apply them to the AIs. So this is different versions of the computational brain that we did, from rat brain, a partial cat brain for the mini and cortical column, and also from the monkey brain and the human brain from the point neuron level of simulation. It's not really precise at the synaptic level, because now we don't really have a connectome for monkey and human brain, but we do have a mesoscale a connectome for the rat brain. In the interest of time, I'm going to skip. I must introducing here that for our explorations of using different versions of the neurons, computational neurons from rats and human, it shows that even at the cellular level, that human neurons win for memory tasks. For example, to give a memory of a square or star or circle or triangle, that within a computational model, that human neurons outperforms much better compared to the rodent neuron. That means for the evolution, that the evolution counts, not only on the connectome level, but also on the single cell level, that the single cell is also evolving for their spike patterns to generate more robust and stable memory. And also the introducing self-feedback of a single neuron to itself also help in machine learning when we create a spiking neural network to recognize different objects. When there aren't, well, because for now the deep neural network only have point neurons. They only project their information to other neurons. They never project back to themselves. But within the human brain, there are many self-feedbacks. So by these computational modeling and the use in AI models, it really shows that self-feedback can help to improve the performance and robustness. And also, we have to realize that these small building blocks like plasticity principles and different type of single neurons, when they come together, some of the complex behaviors like self-organizing collision avoidance at the crowd level, it could happen. So it can emerge from the network, so that it's very much like a Drosophila, how the Drosophila is coordinating with each other in a very small room. When hundreds of them are interacting with each other, well, they don't really hit each other, and this is the modeling from the synaptic level all the way down to the behavior level, how it emerged from the mechanism of reward modulated learning based on spiking neural networks. I think I need to focus on how these different cognitive functions are coordinating with each other at the mind level. I would like to choose the perspective of the self. So we've always been hearing about, I think, therefore I am. Well, no, people say you think, therefore you are, because you're in my perceptual bubble, right? Well, for the current AI model, it's kind of lack the sense of self, just like what Shiman talked about. Although my trying start with agent with the self, well, I think being with a sense of self for the intelligent AI, starting with learning, development, and all the way down to evolution, the agent is exploring and learning through these interactions with the environment, including human, but not limited to them, with all the other AIs, other animals, and also even more complex scenarios, so that the robot with the self can learn not only about themselves, but also how they interact with other agents. So this is when we developed the robot self-recognition model, inspired by the rhesus monkey brain, that my colleague trained the rhesus monkey to pass the mirror self-recognition task. Well, and then we did the AI version that simulate major brain areas of the monkey brain, and then to coordinate them together, without supervised learning, these three robots can recognize which one is themselves, and then when the pointer is pointing to their heads, they can recognize which one is themselves, and avoiding other incorrect judgment to other agents. It does not mean that we have a self-conscious robot. It means that for now, based on our analysis, that the robot without a sense of self now can pass the mirror test. That means the mirror self-recognition cannot be used for judging whether agent or whether a living animals is with self-consciousness or not. Similar things we're doing brain-inspired cognitive empathy, that it is brain-inspired self-conscious, brain-inspired theory of mind model for robots to infer other robots' behavior or thoughts based on his or her own experience. In the interest of time, I have to skip the introduction about the mechanism. And finally, I'm going to some suggestions and proposals for the next 50 years. Is really that everybody is familiar with the imitation game from Alan Turing. Well, you also know that after decades, you need an update. Also, Professor Shi Zhongzhi also mentioned the multiple intelligence of human. Well, the goal of AGI is already right there. That we need a general AI that is with multiple intelligence. Maybe not at the best for each of the tries in different perspectives, but we need a coordinated model that can handle these different tasks within the single model. So this is why we propose the cognitive imitation game. That hopefully that we invite everyone to join us to imitate the human different cognitive functions of human in a coordinated model, in one single model instead of multiple models, and then to gradually reach the level of general intelligence. But to some extent, we also need to ignore some of the negative cognitive functions, like negative emotions, such as envy, hate, or hostility from human beings, so that the brain-inspired or mind-inspired AI model is still beneficial to human. Last but not least, I will have to talk about the mind computation perspective. I think mind computation for the next 50 years, it has to be mind, or in my mind, it has to be mind-centric computational coordination of brain and heart from the becoming for the becoming living in the for the becoming living in the symbiotic society. Not only because the relationship between information coordination between the brain and the heart, but also deeply rooted into the Chinese philosophy back into several hundreds of years ago, when we have the learning of the mind and heart, the theory from Yang-Ming Wang on the mind-heart theory, that the traditional Chinese philosophy talk about the relationship among mind and heart. I'm not quite sure whether the robot need a heart, but before we create a robot brain that achieve human general intelligence, we have to study and get inspirations from the interactions of heart and brain, so that we really understand the nature of heart, the nature of the mind, and how it happens in the physical being of human, and how it can inspire the AI to be with similar cognitive functions. So I think that, like what Shiman and also Michael mentioned, for future AI, we have to consider about how AI interact with human. There are different roles. Now AI is as a tool, but in sci-fi we have AI as competitors to human, and also in Japan, people have AI as quasi-members of the society. So AI may have different roles in future society. So thinking about AI only as a tool or only as slavery, like what Schiman said, is of course not enough. So the Moral Machine book by my friend Wendell and Colin, they've been talking about putting the machine to the moral cage on their Chinese version of the translation on the book interface. Well, then I give them the question, um, if, like 60 years ago, we have robots that cook based on YouTube videos, then you have robots that watch movies together with human, they pretend to do it. Well, on the other side, decades later, it will happen. And then if we have robots with consciousness, with reflexive thinking about how human is treating the robots, and then after decades, so who is in the cage? That will be a fundamental challenge to human. So this is why we need to think about different versions of intelligence, not only human level AGI, super intelligence, but also the human with augmented intelligence such as BCI, the brain computer interface, while also the digital human in the metaverse in the very future, that we have different versions of intelligence. But now we're thinking in a human-centric way. But can we really, keep, the dominance of human in the society? If not, how can we, live in symbiosis with these intelligent beings, different versions of, intelligence that will be very risky to human if we continue our human ethics to the future society. So these are for inspirations to think about for the relationship among living AI with machine. We cannot only have principles for machine to interact with AI, we also need principles for AI to interact, principles for human to interact with AI, as long as they have reflexive thinking and certain levels of consciousness. And also they won't be slaveries. If they are not willing to be slaveries and they have equivalent or very close, cognition to human, what we should do, maybe we need decades to think about, the solutions. Well, also, if we don't start the thinking from now on, we may lose the opportunities, because when we would achieve these levels of intelligence is still unknown to human. So I hope both Michael's and also my intervention in here could inspire the discussion here.